Good morning everyone. In the last class we have done the grouping of cells. That is, we have studied two types of combinations for resistors. One is series combination and another is parallel combination. The next point in the syllabus is again grouping of the series and parallel combination, but it is now with respect to a cell. So we are studying series and parallel combination of cells now. So you should know some elementary points regarding a cell. So let us begin with some definitions for a cell and then we shall come to the actual syllabus. So let us discuss some general points regarding a cell. So in the very first lecture I had told you if you want to have a current in any circuit, you have to connect a cell to it. So once you connect a cell, current begins to flow in the circuit. So an electrolytic cell. So this is what you must have studied in electrochemistry. What is an electrolytic cell? Electrolytic cell consists of a solution, we call it as an electrolyte, and in this electrolyte, two electrodes are dipped. One is a positive electrode, that is we call it as an anode. Another is a negative electrode, that is called as a cathode. So this electrolytic cell consists of an electrolyte in which two electrodes are dipped. So now what happens in a cell is chemical reactions take place inside the electrolyte, and because of those chemical reactions, this chemical energy is converted to electrical energy. So what is a cell, electrolytic cell? It is a device which converts chemical energy to electrical energy. And once you connect a cell in the circuit, this electrical energy is supplied to the charges and then the charges begin to move in the circuit. So on their own, charges do not move in the circuit, isn't it? You have to apply certain potential difference to it. You have to give it an energy to it. So the cell does that work. The cell supplies energy to the charges and thereby the charges start moving in the circuit and you have a current. So this cell converts chemical energy to electrical energy. So this is a small device which maintains current in the circuit. So what is a cell? In all your experiments you are using a cell and you are doing a special experiment for the cells. That is, we are determining the constants for a cell. I will come to those constants later on. So you should know what is a cell. A cell is a device that maintains current in the circuit. Now, what is the symbol for a cell? Everybody know this is the symbol for a cell. The longer side shows you the positive terminal, the shorter side shows you the negative terminal. So this positive and negative, symbolically it is shown like this. So this is the symbol we use in a circuit. This is symbol of a cell. Also, general information is a cell is of two types. Mainly we can divide into two types. One is a primary cell, another is a secondary cell. So what is the difference between primary and secondary? So primary cell, you use on the clock. In the clocks you are using a small cell. Even in your remote control of the TVs you are using a small cell which is having a voltage of 1.5. So what about this cell? Once it is discharged, you don't have to use it again. You cannot recharge it. So the cells which you have, then you don't use it again. So that is nothing but your primary cell. So in the lab we are having two types of primary cells you are using. The one is called as a Daniell cell, another is called as a Leclanché cell. We are actually designing these two cells with electrolytes. In Daniell cell you are having copper sulfate as the electrolyte. In Leclanché cell you are having NH4Cl as the electrolyte. So these cells, if they ask you in the exam for Viva, then you should say that these are nothing but your primary cells which cannot be recharged. They are called as primary cells. Another type is nothing but secondary cells. So secondary cells are those which can be recharged. They can be used again and again. Like your mobile cell, once it is discharged, you connect to a current source and again you use it. So those which can be recharged, we call them as the secondary cells. So all the storage cells, lead accumulator, these are the examples for secondary cells. So cell is divided into two categories, primary and secondary. Primary cannot be recharged and secondary cells can be recharged. So this is about some general points regarding a cell. So we use a cell to maintain current in a circuit. Now for a cell, in your syllabus we are defining three important constants. So what are these constants? So I have written the constants here. First one we are going to define is internal resistance of a cell. Notation you remember, it is always small r, not capital R. So internal resistance of a cell is one constant for a cell. Second one, very important, EMF of cell. Notation is capital E and the full form of EMF is electromotive force of a cell. This is second constant. Another term which we define for a cell, that is nothing but terminal PD. It is denoted by capital V. So this terminal PD I will define when we are doing the derivation. It will be more clear there. First two terms let us define today now. At the start, one is what? Internal resistance of a cell. Very simple definition of resistance. So when we were doing Ohm's law, I had defined resistance. What is the meaning of the word resistance? To resist means to oppose. So what is internal resistance of a cell? So you may think that cell is supplying current to a circuit, so it should not have a internal resistance. But then also, this electrolyte in the cell has got certain resistance. It is very small, but the cell also has got small opposition to the flow of charges. So that opposition offered by a cell to the flow of charges is called as internal resistance, small r. So try to remember the definition very clearly, because this internal resistance you are doing in the lab, you are determining actually the value of internal resistance. So you should know the definitions of internal resistance, and you are also comparing EMF, so you should know what is EMF also. So once again in one line I can define what is internal resistance of a cell. I have written it here. It is the opposition of a cell to the flow of charges through it. So this is a very small quantity. This is the first constant we define for a cell. The second one is very important, that is EMF of a cell. Actually there are two definitions for EMF. I shall start with the conceptual definition, and one more conclusion I have written it here at the end of the derivation. So let us begin with the basic definition of EMF of a cell. So just now I told you, if you want current in a circuit, you have to connect a cell to it. So the cell will provide electrical energy to the charges. Now, when you connect a cell, there is a flow of current. The meaning is the charges begin to move. What is current? Current is nothing but flow of charges. So when you connect a cell, charges begin to move in the circuit. So when charges begin to move in a circuit, always work is done. So to move the charges in a circuit, we have done in the second chapter, W, work done, is equals to Q into V. If a charge Q moves under a potential difference V, work done is given by W is equals to QV. So you have to remember one point very clearly, whenever the charges move in a circuit, work is done. Now here also, when you connect a cell in a circuit, there is a flow of charges. So work is done by the cell to move the charges in the circuit. So with reference to the work done by the cell, this we define constant as EMF of a cell. So how to define EMF of a cell? A very basic definition of EMF of a cell is, it is the work done by the cell to move unit positive charge in the circuit. The meaning is +1 coulomb of charge. If you want to move to the complete circuit in which the cell is connected, then whatever work is done, that is called as EMF of the cell. So try to remember the definition very clearly. I will define it once again. EMF of a cell is work done by the cell to move unit positive charge in the circuit. Now with this definition in mind, we have two definitions, internal resistance and EMF. Then we shall find out the relation between E and V. I will tell you about V later on in the derivation itself. So let us take a very simple circuit. What is the circuit? You can see it very clearly here. We have a cell here. Then E and R. So you know what is E? E is EMF of a cell. Small r is internal resistance of a cell. And this cell with constants E and R, it is connected to an external resistance. What is the value of the external resistance? It is capital R. Don't get confused between small r and capital R. I have written it very clearly over here. Small r always stands for internal resistance of a cell, and whatever external resistance you connect, that is called as capital R. So R and R. So this is small r for a cell, outside resistance is capital R. Now you want to have current through the resistor. So you have connected a cell to a resistor. Once you connect a cell to a resistor, just now I told you, a cell will maintain current in the circuit. Then current begins to flow in the circuit. So I is the current that is flowing in the circuit. So because of this cell, the current I is flowing in the circuit. What is current? The flow of charges. So whenever the charges move, what is done? Work is done. So now I is the current, therefore work is done in the circuit. So we shall write down the value of EMF of a cell. Suppose in the circuit, plus 1 coulomb of charge is moving in the circuit. So to move plus 1 coulomb of charge in the circuit, work done, we call it as what? EMF of the cell. So we shall first begin with the definition of EMF of a cell. What is EMF of a cell? Work done to move unit positive charge in the circuit. Now the circuit, if you observe the circuit, it is a very simple circuit. Only two oppositions are there in the circuit. What are the two oppositions to the current? One is the external resistance. Another is the internal resistance. So this unit charge, plus 1 charge, will first move through R, and then inside the cell there is one resistance, small resistance, that is R. So this plus 1 charge should move through capital R, and it should also move through small r. So the circuit is made up of only two components. So I shall write work done to move unit charge in the circuit. The circuit is made up of two resistors. So it is work done to move the charge through capital R plus work done to move the charge through small r. So now I have written the definition of EMF here. Work done to move unit charge in the circuit. By definition, it is nothing but EMF of the cell. So this side, left hand side becomes equals to EMF of the cell. Now, work done to move unit charge through R. Suppose plus 1 coulomb of charge, you are moving from this point to this point. So by definition, PD, potential difference. What is potential difference? Potential difference between any 2 points is nothing but work done to move plus 1 charge from one point to another. So this work done to move unit charge through capital R will become nothing but potential difference across R. And work done to move unit charge through small r will become potential difference across small r. So we have, let us denote this potential difference as V. The other potential difference I will denote as V dash. So what equation you get for E? E is PD across capital R, that is V, and PD across small r, that is V dash. So we get one very important equation. E is equals to V plus V dash. Let us call this equation as 1. Now, we shall use Ohm's law and we shall put the values of V and V dash. By Ohm's law, what is your Ohm's law? V is equals to I into R. Now, what is V? V is the PD across R, so current into resistance. So, V will be equals to I into capital R. What is V dash? V dash is the potential difference across small r. So it is again the product of current R and small r. So you got an equation for V, you got an equation for V dash. You substitute for V and V dash over here. So what will you get? You will get E is equals to IR plus IR. Take I common, it will be R plus R. Then take I on one side, I will be equals to E upon R plus R. This is a very important equation. Many problems, 5 marks problems, they are based on this equation. So I have written in words also very clearly this equation. I, what does I stand for? Current in the circuit. What is E? E is EMF of a cell. What is capital R? The external resistance. And what is small r? The internal resistance. So this equation you remember for solving problems. I is equals to E upon R plus R. Now, from equation 1, we shall go to the other definition of EMF. This is your equation 1. Let us take V on one side. So what will be V then? E minus V dash. So I have written it here. From equation 1, V is equals to E minus V dash. V dash you already know what is the value of V dash. V dash you have written it as I into small. So I have put the value of V dash as I into R. So we have this equation now. V is equals to E minus IR. This is the relation between V and E. Observe the equation very carefully. What is V? V is equals to E minus IR. Now let us write a name for this term V. I have written it here. V is nothing but terminal PD. Try to understand this term very clearly. V is called as terminal PD. Value of V is nothing but I into R, where R is the external resistance. What is terminal PD? So terminal PD is defined like this. Now you can see the figure. The cell is connected between the points A and B. R is also connected between the same points A and B. So what is the PD across R will be nothing but PD across the terminals of the cell, right? Because these two are in parallel. Both are connected between the points A and B. So whatever is the PD across R is nothing but PD across the cell. So this PD across the cell, that is PD between the terminals of the cell. But what is the condition? Current should be flowing in the circuit. So whenever current flows in the circuit, that circuit is called as what circuit? A closed circuit, right? So terminal PD is defined as the potential difference between the terminals of the cell in what circuit? Closed circuit. What is the meaning of closed circuit? Current is drawn from the cell. So that this is the meaning of terminal PD. How do you measure terminal PD? Terminal PD is equals to I into R. I is the current, R is the external resistance. So I will repeat once again. PD across R is equals to PD across the cell, because both are connected between the same 2 points AB. So this value V is equals to IR is called as terminal PD. Remember the definition very clearly. I have written it here. It is the potential difference between the terminals of the cell under what condition? In closed circuit, when I flows in the circuit. So this V is equals to IR is called as terminal PD. So terminal PD is equals to E minus IR. E is the EMF, small r is the resistance, internal resistance. This relation is very important in your other future coming derivations, cells in series, cells in parallel. We are using this basic relation. V is equals to E minus IR. From this relation, you can get another definition of EMF of a cell. Now, two conclusions you can draw from this equation. V is equals to E minus IR. E minus something. So, which is greater? From E, if you subtract IR, then you get V. So, which is greater quantity here? That is, E is greater than V. So, V is always less than E when current is drawn from the cell. When it is getting discharged, V is always less than E. For CET, they ask you another question. When the cell is charged, it is reverse. It is V is greater than E. But for discharging mode, V is always less than E. This is one conclusion. Another conclusion from this equation is, let us put I equals to 0 here. No current is drawn from the cell. If no current is drawn from the cell, what circuit it becomes? It becomes an open circuit. So if you put I equals to 0, what condition you will get? E is equals to V. Right? So now this is another definition for E. What is the meaning of E? E is equals to terminal PD. But under what condition? Open circuit. So other definition of EMF is also here. What is that EMF? EMF is same, this definition only you have to repeat here. Only one change. Here it was closed circuit. Now you will make it as what? Open circuit. So what is the other definition of terminal PD? Other definition of EMF? It is the PD between the terminals of the cell in the open circuit. Open circuit means no current flows in the circuit. So whichever is easy definition, that you can write in your exam. Either you write this definition or this definition. This is actually the basic concept. From this concept, this is actually conclusion. Right? So I think this is very easy to remember. You can also remember this definition. Now, only I will tell you the three main points and the three important definitions in today's session. So what are the three important definitions? First one, what is a cell? A cell an electrolytic cell converts chemical energy to electrical energy. A cell is a device that maintains current in the circuit. Two types of cells are there, primary and secondary. For any cell, we define two main constants. One is internal resistance, another is EMF of a cell. Internal resistance is smaller. What is internal resistance? Opposition of a cell to the flow of charges. And what is EMF of a cell? Basic definition is work done by the cell to move unit charge in the circuit. Now, we have a relation between internal resistance and EMF of a cell. From that relation, we come to this conclusion. This is a very important conclusion. I is equals to E upon R plus R. And also, we come to this relation. If I is equals to 0, E is equals to V. So, we will have another definition for EMF of a cell. EMF of a cell is nothing but PD between the terminals of the cell in the open circuit. Now, you can tell me what are the two main differences between terminal PD and EMF. One difference is very clear. What is terminal PD and what is EMF? Terminal PD means what? The potential difference between terminals of the cell in the closed circuit, and this is potential difference between the terminals of the cell in the open circuit. This is one difference between V and E. Another difference is also that V is equals to IR. Means V depends upon two quantities. What are the two quantities? It depends upon the current and it depends upon the external resistance. V depends upon I and R. Whereas EMF of a cell is constant. Like suppose you take a small cell, purchase it from the market. The voltage on that will be 1.5 volt. So what is this 1.5 volt? It is constant for that cell and it is called as EMF of the cell. So it does not depend upon the current drawn or the external resistance. So this EMF of a cell is always constant for a given cell, whereas V depends upon the current drawn and the external resistance. If the resistance changes, then terminal PD also changes. So you have to remember three important definitions: internal resistance, EMF and terminal PD. Even if this derivation is not yet asked so far because it is quite a conceptual derivation, but the conclusions of the derivations are very important. One equation is used in the problem. This is I equation, current equation. Another relation we are using for the next derivations, V is equals to E minus IR. Now I will tell you regarding the problems that is based on this. Now one thing you may feel that R should be always a single resistance. R is never, it can be a combination of resistance. That is the problems asked in your final exam. That is, they give a circuit clearly, but here instead of one resistance, many resistors can be there. Say here this is R1, then you can have again a combination like this. Now here, this complete thing is nothing but your external resistance. So when you are going to the problems, when you want to find out the value of capital R, you have to use the laws of series combination, parallel combination, find out the effective resistance of all that series and parallel, and that R you have to substitute here. Don't think that R is always a single resistance. For simplicity, for the derivation I have taken a single resistance. But in the problems, if you see, you will have number of resistances like this. So when you have a number of resistances, maybe in series, maybe in parallel, find out the effective value of all this using your laws, and then that effective value you have to substitute here, and then you will get current in the circuit. So this is used mainly for the problems. This equation is used for the problems, and this is for another definition of the EMF of a cell. So what is very important in today's session is the three definitions: internal resistance, EMF and terminal PD. Then we have a conceptual derivation for connecting the three, and we have two important conclusions here. This is mainly for the problems and this is for the next subsequent derivations. So this is all for today's session. Thank you.